Hello, you are on the Another Space channel.
Along with Earth and Mars, Mercury and Venus make up our inner solar system. Jupiter, Saturn, Uranus, and Neptune, these planets farthest from the Sun, make up the gaseous outer worlds of the solar system. Over 4 billion years, the inner planets bound enough interstellar debris to become rock solid.
Why do we study planets? Why do we study astronomy at all? We someday need to go beyond the planet Earth if we expect to survive as a species for a very long time. And we need to know what's out there and what the nature of the universe is.
We're studying worlds where things are exotic, but the basic processes of physics and chemistry at work are really the same that we see here on Earth.
Millions of miles separate us from our rocky cousins. But a tour around Venus and Mercury reveals a common DNA.
We can go to Mercury and Venus and really look at these as places, as worlds with their own histories, and then contextualize our own planet's history.
Venus is the 6th largest planet in the solar system. At its closest, it is 26 million miles away from Earth. A year on Venus lasts 225 Earth days. And if you weighed 150 pounds on Earth, you'd weigh 136 on Venus. Venus. When the ancient Romans looked up, they were captivated by its commanding presence. They named the planet after their serene goddess of love and beauty.
It's such a beautiful presence in the sky. It seems obvious the connection there.
Venus has long been considered our sister planet because of its closeness in composition, gravity, density, and size.
Venus and Earth are almost twins in a lot of ways. They're almost the same size. Venus is slightly smaller than Earth. So if Earth was a regulation basketball, Venus is a soccer ball, slightly smaller. And Venus is the closest planet to Earth. So for a long time, it was thought of literally as a twin planet.
For ages, scientists thought this twin, like Earth, was a planet covered with deep oceans, lush rainforests, and had a climate that would give credibility to the notion that intelligent life could exist there.
Before the space age, people thought it might be very Earth-like on Venus. But the paradox is when we actually got to Venus and started exploring it, the conditions there are so different.
It turned out Venus was less of an exotic sister to Earth and more of an evil twin.
So here you have two very similar planets in their sort of bulk properties, but they've evolved to such different states. And that creates an interesting problem of understanding planetary evolution in a sort of controlled experiment. Take these two similar planets and let them go for 4 billion years, and then why do they end up so different?
First, some of the basic differences. Venus has been hit hard with meteors. One so strong that some scientists think it may have reversed the planet's rotation.
Venus has a very slow rotation, and it has what we call a retrograde rotation. So it spins backwards compared to the direction of spin of all the other planets.
Because of this retrograde rotation, the Sun rises in the west and sets in the east. And the Venusian days are long ones. The amount of time from one sunrise to the next is about 8 Earth months. But the orbital pattern and long days aren't what make Venus so intolerable. In part, it's the wicked climate. With a surface temperature of 900 degrees Fahrenheit, Venus is the hottest planet in the solar system. Travelers there would have their trip cut short in no time.
It would take a matter of seconds, maybe 1 second before they were gone, roasted to death.
If you're an astronaut sitting on Venus without a spacesuit, then your skin's going to crisp up. You're going to cook just like a turkey in an oven, except much faster.
The unforgiving heat wave is created by a process called the greenhouse effect, the identical process that keeps Earth's climate in check and teeming with life. But a closer look at Venus tells us how this common trait can be a cycle of life and a cycle of death. Today, our own temperature is on the rise, and scientists found the possible cause behind it up on Venus.
Global warming is a result of greenhouse gases that are growing and growing and growing, and therefore we're getting hotter and hotter. And when we looked at Venus, we said, aha, here it is actually happening.
In the 1990s, after the Magellan spacecraft was launched, planetary watchdogs began turning to Venus to surmise just how bad it could get here on Earth.
Space exploration has told us a lot about the Earth and the environment it's in. And in fact, the greenhouse effect that everybody's talking about with global warming was actually discovered on Venus.
What they found out about Venus shed new light on how fragile Earth's greenhouse effect really is.
Venus didn't always used to be this hot. We think that early in its history, it was more Earth-like on the surface, and it lost its oceans due to what we call a runaway greenhouse effect. So Venus is an example that certainly a global change can happen on a planet in sort of a worst-case scenario. We don't have to turn Earth into Venus before we're in trouble. We just have to move a little bit in that direction, and we are moving in that direction. But the real value of studying Venus, it allows us to test our climate models.
Through computerized general circulation models, or GCMs, scientists were able to calculate temperature increases on Earth based on the amount of greenhouse gases on Venus. So just how does Venus's greenhouse effect work and make the planet so hot? This is Biosphere 2. Located along the foothills of Arizona's Santa Catalina Mountains, it was built by a group of researchers to explore the idea of colonizing other planets. It is the largest greenhouse on Earth.
Biosphere is a perfect example of a greenhouse because it's a big building with glass panes that let the sun in, and the air is really hot in here.
The solar rays that penetrate the glass panes cause the temperature inside to rise.
The air heats up, but then the air cannot escape, cannot move vertically into the atmosphere because of the walls.
The windows trap the heat, warm the building, and provide the plants and trees with a livable climate. On Venus, greenhouse gases don't exactly trap the sun's heat, but they greatly slow the rate at which it can escape.
The greenhouse effect on any planet is a situation where the surface temperature becomes hotter because of gases in the atmosphere that trap the heat while letting in the sunlight.
These same greenhouse gases that would prove to be fatal to us on Venus are essential to life on Earth.
Without the greenhouse effect, the average temperature would be far below freezing, the oceans would be totally or almost totally frozen, and it's not even clear if life would exist on the Earth.
We talked about how hot it was, but why is it so hot? The answer has to do with the atmospheric composition. It's almost all carbon dioxide there.
Carbon dioxide, or CO2, makes up 95% of the Venusian atmosphere. And that high volume of gas traps more heat.
That's going to give you a strong greenhouse effect, and that's going to make it really hot. And that's why it's so hot on Venus. It's an extreme example of global warming. So all the CO2 just builds up in the atmosphere on Venus, which just makes it hotter and hotter.
The 900-degree heat isn't the only trait that makes Earth's twin seem a menace. 30 miles above the scorching ground of Venus, there's havoc occurring on the planet that makes 900 degrees Fahrenheit feel like a cold front. Electrical mayhem, where split-second jolts can reach 50,000 degrees. Each spark of light contains 100 million volts of electricity. Lightning occurs on both Earth and Venus when electrical charges store up enough energy until they release a spark. Mears Oppenheim teaches planetary physics to students at Boston University. And researchers like him get in on the action at Boston's Museum of Science. In their caged lighting exhibit, 30-foot-high domes motor up to simulate how lightning is generated on Venus. And then, it's showtime.
So look at this, generating so many millions of volts on these domes that voltage has to escape, and it's actually ripping molecules in the air apart.
The air in the domes, like within the Venusian clouds, stirs up the electrical distribution of tiny atomic molecules.
So the ripped molecules make that light as they reassemble themselves, and that's what a lightning bolt is.
Cosmic particles from exploding stars way out in the galaxy trigger lightning. When these hit the atmosphere, they provide that spark.
These are particles that come from way out in the universe into the atmosphere and cause a shower of charged particles. And on Venus, you probably have real lightning to the extreme extent that contain enormous amounts of energy and go for miles and miles.
On average, lightning hits the Earth more than 3.1 billion times a year. The number of times lightning hits the ground on Venus? 0. The atmospheric pressure on Venus is 90 times greater than on Earth because the weight of the atmosphere created by gases is heavier. This prevents Venusian lightning from hitting hard ground. Instead, it is restrained in clouds.
There's just too much resistance in that very thick air for a lightning bolt to get through. It's much easier for lightning to discharge from cloud to cloud.
And besides appearance, there's little else that's Earth-like about Venusian clouds. In fact, the main ingredient that creates them is toxic enough to burn through human flesh. From Earth, you might be able to see Venus twinkle in the morning and evening skies like a star.
Definitely not a wallflower. It's so bright in our sky, not just because it's the closest planet to us, but because it's the most reflective planet. Because it turns out Venus is completely covered in these bright reflective clouds.
80% of the sun's light bounces off the clouds that blanket the planet. But even in the clouds, Venus, our so-called twin planet, manages to show an evil nature.
And we know that the clouds of Venus are made out of sulfuric acid, basically like battery acid. And that sulfuric acid is made by sulfur dioxide coming out of volcanoes on the surface.
So if a traveler to Venus could survive the acidic clouds, the lightning bolts, the toxic air, and the heat, just how would the Venusian surface look? At 5 miles high, Mont Mons is the largest volcano on Venus. And it's left some tremendous lava channels in its wake, just like Kilauea did.
Now, as you can see, the structure, we have levees here on the sides, and then internal structures as well. This is similar, perhaps, to how large channels called canali formed on the surface of Venus. However, they formed at a much larger scale.
Large enough to create seemingly endless miles of canali across the Venusian landscape. Consistent in both width and depth, The canali are much longer on Venus than on Hawaii because of environmental conditions on the planet. The dense atmosphere and hot temperature slows the magma from cooling into solid rock. And with little wind and no rain to further cool the magma, lava can cut through the surface for months after an eruption before it hardens.
On Venus, if you did see layering, you would expect to see layer after layer of volcanic rocks that would all be relatively black and basaltic in composition. You would probably see a little bit of color due to potentially oxidized iron, which would look red. Typically, basaltic lava flows are glassy enough that, in fact, you would actually cut your hand. They can be extremely sharp. They tend to quench and form glass.
And then there are the skies. That heavy Venusian cloud cover diffuses most of the direct sunlight.
It would be a lot darker on the surface of Venus during the day than it would be here on Earth. Also, because the light is scattered very efficiently, you tend to lose shadows. So everything is lit fairly consistently across the surface. And then additionally, because of the composition of the atmosphere, everything would tend to have more of an orangish tinge to it.
Besides canyons, jagged mountain ranges scrape the Venusian skies. The planet's highest peak is on Maxwell Mons.
Maxwell is about 35,000 feet high, which puts it at a healthy distance above Mount Everest or any mountain on Earth. Everest is something like 28,000 feet high. So it's definitely larger than anything on Earth.
Our sister planet seems to have outdone one of our 7 natural wonders. But how would the Venusian terrain measure up against another geologic feature, our canyons? The Grand Canyon, a great chasm eroded over 250 million years by the Colorado River.
When the Colorado Plateau was uplifted millions of years ago, it gave the water more energy to cut back through the canyon and wear away the rocks.
The vast canyons on Venus may have also been formed by erosion, but not by a river.
Volcanic systems can erode canyons by having fluid flow if it's very fluid, not very viscous. Materials can erode similar to water, and the Grand Canyon is only part of the Colorado River system, but even looking at the Colorado River system as a whole, it's not nearly as long as the longest channels on Venus.
Had the ancient Romans known about the volcanoes, acidic clouds, lightning bolts, toxic air, and that scorching heat, perhaps they may have named our evil twin planet after something other than their goddess of beauty and love.
There's irony there because, of course, the Greeks and Romans didn't know anything about the conditions on Venus. Then, here we are a couple of thousand years later and we're actually exploring this place, and it's not quite so nice according to our tastes.